Hello, geometry students. Let's continue our notes on 9-1 polygons in the coordinate plane. For example 3, we are classifying a parallelogram. Remember, it will have 4 sides, and 2 of those sides will be, or opposite sides will be parallel. And number 3, the vertices of a parallelogram are, that means the points, -2, so left 2, comma 2, that's A. 4, comma 6, right 4 up 6, that's B. C is 6, comma 3. And D is 0, which means we don't go left or right, -1, so we go down 1. We're going to connect these to create a parallelogram. And the question is asking, is this a rhombus? Well, are the sides equal in measure? Because opposite sides must be, actually I think a rhombus, all sides must be congruent. So no, all sides are not congruent. It's a parallelogram, but it is not a rhombus. Is ABCD a rectangle? Explain. To be a rectangle, it would have to have all angles equal to 90 degrees. So we would have to figure out, are they 90 degrees? Let's start with angle ABC. Is it 90 degrees? To figure that out, we need to know if the slopes are perpendicular, meaning are they negative reciprocals? So let's go from A to B. The slope is the change in y over the change in x. So the y's would be 6 minus 2, and the x's would be 4 minus -2. This is for the slope for AB. So that equals 4, and in the denominator, 4 minus -2 changes to plus, so 4 plus 2 is 6. That equals 2/3. So that is the slope for AB. Is the slope for BC? Change colors and highlighter. BC. So the slope for those, the change in y would be 3 minus 6 and 6 minus 4. That equals -3 over 2. Well, that is showing that, highlight these, this slope is 2/3. This slope is -3 over 2. So that is showing that they are negative reciprocals. So that means that this angle is 90 degrees. Angle ABC is 90 degrees because they're negative reciprocals. Now we want to figure out if that's true, and this makes a straight line, then this also is 90 degrees. And, right? I think that's true. I guess no, it doesn't prove that, so we have to prove that. So is angle BCD 90 degrees? And we can prove that by figuring out their slopes. Let's do the slopes this time by using rise over run. So I'm going to go down 3 over 2. So from B to C, we already figured that one out. So BC is We already figured that out. It's down 3 over 2. And we figured that out over here. So now we just need to figure out CD. So I'm going up 1, 2, 3. And I'm going over 1, 2, 3, 4. Oh, I didn't go up far enough. To get to C to B, C to D. Go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. So for D to C, I went up 4 over 6, which reduces to 2/3, which is the negative reciprocal to BC. So I'm going to just erase my little slope marks. Oops. And that is showing us that this is 90 degrees as well. If that's 90 degrees, I can pretty much visually see that the other ones are 90 degrees as well. All right, so this would show us that angle BCD is equal to 90 degrees. So is it a rectangle? Yes. For example 4, we now want to know if the quadrilateral is a kite, trapezoid, or neither. Now these are not parallelograms, right? So parallelogram could be a rhombus, it could be a square, it could be a rectangle, but kites are just quadrilaterals. So a kite and a trapezoid, those just have 4 sides, but they're special for different reasons. A kite has to have 2 pairs of congruent sides. So this side would have to be congruent to that side, and these sides would have to be congruent. So let's see if they are. Well, I can count the squares here. That's 4, and this is 4. To figure out QR and SR, we have to use the distance formula. So we're going to add subtract the x's. 7 minus 2 is 5. We're going to square it. 6 minus 5 is 1. We're going to square it. So that's 25 plus 1. That's the square root of 26. So the distance formula, we have to take the square root. Now let's find SR. From S to R, the x's are 7 minus 6, that's 1. 6 minus 1 is 5. That's also the square root of 26. So we can label this the square root of 26 and the square root of 26. So we have one condition for it to be a kite, that the sides are equal. The other condition is that these diagonals must be perpendicular, and we saw that when we built our kites. It looks like they're 90 degrees, but let's just practice our slope formula. Well, actually I can see from Q to S, so we're figuring out slope. From Q to S, I'm going down 4 over 4. So negative 4 over 4 equals negative 1. Now I want to find P to R. What is the slope from P to R? Well, the x's, or the y's, remember the y's go on top, is 6 minus 5, or 6 minus 1, and 7 minus 2. That is equal to 5 over 5, which is equal to 1. Are 1 and negative 1 negative reciprocals? If I flip 1, do I get 1? Yes, so they are negative reciprocals. Just going to abbreviate that. Negative reciprocals, so perpendicular. For 4b, is the quadrilateral a kite, trapezoid, or neither? Same question. Oh, so we should have said back here that this was a kite. It's a kite because we proved it, saying that the diagonals were perpendicular and the sides were congruent. Is this a trapezoid? Well, to be a trapezoid, you have to have a pair of parallel sides, opposite sides, a pair of opposite sides are parallel. So these sides are definitely not parallel. Are these sides parallel? We would have to figure out, do they have the same slope? So let's figure out their slopes. So for the first side, we have x, y, x and y. The change in y would be 7 minus 5, and the change in x would be 4 minus 7. That is equal to 2 over negative 3. Now we have to figure it out for w and z. So the y's are 2 minus 1. The x's are 2 minus 4. That equals 1 over negative 2. Are these slopes the same? No, so it's not a trapezoid. So it would be neither. It's not a trapezoid, it's not a kite. Okay, example 5. Find perimeter and area. And so we're problem solving now, kind of a real world problem. Dylan draws up a plan to fence in a yard for his chickens. The distance between grid lines is 1 foot. So he's going to make a triangular yard for his chickens. Is 30 feet enough fencing to enclose the yard? So we need to figure out the perimeter. So we need to figure out the distance from A to B first. What would that distance be? Well, we have to subtract the x's, 10 minus 2, square it. We have to subtract the y's, 12 minus 6, square it, and take the square root. 10 minus 2 is 8. Square it. 12 minus 6 is 6. Square it. So that's 64 plus 36, which is 100. And the square root of 100 is 10. That was the distance for A to B. Now let's figure out the distance from B to C. So I will subtract the x's, that's 0. 10 minus 10 is 0. Square it. And 12 minus 2 is 10. Square it. 0 is just 0, and 10 squared is 100. So the square root of 100 is equal to 10. That is for BC. So we have 10 and 10. And now we have to figure out from C to A. So the x's are 10 minus 2, which is 8 squared. And 2 minus 6 is negative 4 squared. And we have to take the square root. 8 squared, 64. Negative 4 squared, 16. Add them, take the square root. So that's going to be 80. I know that the square root of 81 is 9 because 9 times 9 is 81. So this is pretty close to 9. It's a little bit less. It's 8 point something, like 8.9. You can figure it out in your calculator, but I don't really need to because this 10 plus this 10 plus something a little bit less than 9 is close to 29 feet. and he has 30 feet of fencing. So 29 feet is less than 30 feet. So yes, he has enough fencing. For part B, it says for a healthy flock, each chicken needs at least 8 square feet of space. That's an area. What is the maximum number of chickens Dylan can put in there? Well, to figure that out, we need to know what the area of the triangle is. And the easiest way I can see, since I need to figure out a height and a base, because the area of a triangle is equal to 1/2 the base times the height. I am going to use this line here as the height because it's perpendicular to the base. Okay, and I can figure out easily that distance because it goes from 2 on the x-axis to 10 on the x-axis. If I count the squares, it's 8 feet. And if I count the squares here for the base, it's 10 feet. Now I just need to plug that into my triangle formula. So 1/2, the base is 10, the height is 8. That equals 40 square feet. Now, he needs at least 8 square feet per chicken. If I divide 40 feet squared by 8 square feet, I get 5 chickens. And that completes our notes for 9-1.